It's okay.
Rose. You are most welcome to the Experts Corner. And our special guest today is from Zimbabwe, and he will let us know more about himself. Hamilton?
Welcome our viewers, welcome our listeners. Thank you very much, Rose, for the opportunity. My name is Hamilton Katsvairo. I'm a data scientist by training. By passion, I'm a child development researcher. I like embracing artificial intelligence and machine learning to understand better our teenagers so that as parents we can lead as caregivers and policymakers, they will appreciate the developmental stages which our children go through so that they can guide them with the brain in mind.
Um, Thank you so much for the introduction. So today we are talking about,
Welcome.
we are going to talk about machine learning. And machine learning is more of studying of computer algorithms, like the way you said. So our viewers are really eager to hear from you what is machine learning and what it entails. Hamilton, go ahead and take us through this.
Oh, thank you very much. It's a pleasure to explain to our viewers so that they can appreciate machine learning and the potential it has in our lives. So basically, machine learning, we are talking about the practice of programming computers so that they can learn from data. We'll be using algorithms which we teach, and these algorithms, they can actually and automatically improve through experience. So basically, machine learning, we have about three types of machine learning. The first type of machine learning is what we call supervised learning. On supervised learning, we expose the computer to data, but the data we divide it into two so that we have what we call training data, but the training data we label it. Then we have what you call the testing data. For example, a machine, we can give a machine some pictures of oranges, then we label the pictures, then we feed into the model. After feeding to the model, we evaluate so that we learn, or we be sure that the machine is can actually label the output data. So on supervised learning, we have what we call training data and we have what you call test data, so that the machine can learn from the training data. Then we can test to see that, to see if the machine can actually predict the desired output. So we have another type of machine learning, which we call unsupervised learning. On unsupervised learning, what we are trying to do, we give a machine a lot of data. From that data, we leave the machine to check for some similarities and patterns from the data so that it can classify the data according to its patterns. Then it can actually predict the data which we give it so that it can classify and put it according to the clusters. Then we have the third type of machine learning, which we call, uh, we have number one, I said, we have supervised learning, we have unsupervised learning, then we have what we call reinforcement learning. On reinforcement learning, we leave the machine to actually navigate through the data. So from experiences, it gets what we call some rewards. So after getting the rewards, it can actually improve with time. The algorithms on reinforcement learning, they are normally used in games, and even in banking sectors, they use that type of algorithm. So I want viewers and listeners to appreciate the difference between machine learning, artificial intelligence, and deep learning. When we talk of artificial intelligence, actually we are saying it's a program that can sense, reason, and act and adapt. So basically, artificial intelligence, we are saying it's a general program which we which we actually train, which we actually program so that it can sense, reason, act, and adapt. Then on machine learning, we are talking about algorithms whose performance improve as they are exposed to more data over time actually. Then deep learning, it's a subset of machine learning which have got some layered neural networks, and these neural networks, they learn from vast amounts of data. So machine learning, it's an intersection or a combination of statistics which we use in inferring data. Then it also uses a bit of mathematics for modeling. It also uses computer science for implementing algorithms. So when we talk of machine learning, we are talking of a combination of statistics for inferring data, mathematics for coming up with machine learning models, and computer science for implementing algorithms. So maybe our listeners and viewers, they need to appreciate that for us to have a machine learning model, we should have what we call input data, which we feed into a model. The model should analyze the data, should look for patterns. Then using the past data, the model should be able to predict what is likely to happen. So basically, that's the essence of a model in machine learning. It should take in data, then it should analyze, check for patterns, then use that data to predict. On supervised learning, as I have indicated, we have what we call classification algorithms. The classification algorithms, they can be used on fraud detection, they can be used on email spam detection, they can also be used in hospitals, especially on diagnostics or even on image classifications. Then we have also regression algorithms in supervised learning. The regression algorithms, they can be used on score prediction as well as on risk assessment. Under supervised learning, we have things like text mining, face recognition, or big data visualization, as well as city planning. We can use those algorithms for things like that. Now, I want my viewers and listeners to appreciate that machine learning is very important, especially in this era of Industry 4.0, whereby we have a lot of data, and this data in terms of volume is too much. So we need to have some insights from that data. We have also data which is very varied in terms of variety of data. Some data, it will be structured, unstructured, and semi-structured. Even to get the value from that data, which is very huge, we need some algorithms which we can use so that we can extract some insights and some value from that data. On preparing data, what I mean is we need to remove some missing value or some noise from the data so that the data will be fit, because the quality of data will determine the quality of the output of what we are trying to achieve. So on second stage, which is preparing the data, we need to remove some noises. We need to synchronize the data so that it becomes clean. So first stage is gathering data. Second stage is preparing that data. Then third stage is choosing a model. As I have highlighted, we have supervised learning, we have unsupervised learning, we have reinforcement learning. So on choosing the model, it means we are choosing either supervised algorithms which fall under supervised learning or unsupervised learning or reinforcement learning. Then on fourth stage, we have training. On training, we'll be now feeding our algorithms into the model. Maybe we need to feed the labeled data or unlabeled data, whatever the model which we have chosen. On fifth stage, we have evaluation. We'll be evaluating our model. Then on the sixth stage, we have what we call hyperparameter tuning. Then lastly, we have prediction on the seventh stage. So just a recap, our machine learning model has 7 stages. Stage number 1, gathering data. Stage number 2, preparing that data. Number 3, choosing a model. Number 4, training the model. Number 5, evaluating the model. Number 6, hyperparameter tuning. Then lastly, number 7, predicting what is likely to happen. Now, we have some applications for machine learning like classification, prediction, extraction, regression, learning associations, statistical arbitrage, medical diagnosis, image and speech recognition. Now, my viewers and listeners, they might have a question, especially on the best way to learn machine learning. Firstly, for a person to learn machine learning, he or she should have strength in basic mathematics. After having strength, stage number 2, a person should master statistical techniques and their methods. Then they should also understand machine learning algorithms. Then also, they should also grasp some concepts of data learning and analysis. Then lastly, they should have passion on practicing as well as reading some books on machine learning. So if our viewers and listeners, they want to learn machine learning, they should have an interest in mathematics, in statistics, as well as programming languages like R as well as Python. Now, we have some use case examples for machine learning. Like, for example, we have self-driving Google car. We have some web search results. We have social listening applications. We have market pricing models. We have as well credit scoring. We have pattern recognition. We have fraud detection. All these are use cases of machine learning. Now, opportunities which we can have on using machine learning include things like process automation. On process automation, what I mean is there are some tasks which we use, which we do manually. When we embrace machine learning, we can actually be able to automate those processes as well as optimize those processes. We can actually be able to predict things which are likely to happen by using past and present data. We can predict what is likely to happen. Machine learning as well can also be applied on marketing. For example, we can actually be able to understand user experience, then improve it. We can actually be able to understand what we call customer service improvement. So there are a lot of things which we can do by machine learning. So I would urge my users, I would urge our viewers and listeners. So I was saying machine learning, that's the way to go, especially in this data technology revolution. I think as an introduction, I think this is enough for users, Rose.
Oh yeah, you've actually explained everything in depth, and thank you so much for joining me today, Ham.
I really appreciate.
Oh yeah, and to our viewers, thank you so much for watching. Hit the subscribe button so that you don't miss out on more of the upcoming sessions that are coming. Thank you, Ham, for joining me today.
My pleasure, Rose.
Okay.